Assalamualaikum, my name is Muhammad Afiq bin Mohtar. In this video, our group will present and explain the Electric Circuit 1 group project, and we are from group 4. First, I will introduce our group members, which is me, Muhammad Afiq bin Mohtar. Second, we have Amira Najiha binti Muhammad Zain. And third, we have Nurin Shasha binti Roshdan. For introduction, basically electric circuit is a pathway for electric current to flow. And for this group project, we required to use a different method or rules to calculate a different value in this electric circuit. Two basic rules that can explain the value in the electric circuit, and we use it in this group project, which is the Ohm's law and the Kirchhoff's law. In this group project, we also use simulation tools, which is the Proteus, to evaluate and verify our answer in the calculation. Next, this is the method that we use in this group project. First, we have the Kirchhoff current law, the Kirchhoff voltage law, nodal analysis, mesh analysis, and source transformation. Now, I will explain the calculation at task 1. In the task 1, the question needs us to calculate the voltage value at node V1 and V2 by using the nodal analysis. A nodal analysis is a method to calculate the value of voltage between the nodes in the electric circuit. So, for using the nodal analysis, we apply the Kirchhoff current law. The Kirchhoff current law stated that the current entering equal to current leaving. First, we will label the current entering and current leaving for each nodes. After we label, and we create an equation by using the KCL at node V1. For V1, I1 plus I3, which is the current entering, equal to I2 plus I4, which is the current leaving. At I1, we have 2 ampere plus, and right here we apply the Ohm's law. From the Ohm's law, we can find the current by dividing the voltage and the resistor. For the voltage, the high voltage need to minus the low voltage and divide by the resistor. And from there, we can create V2 minus V1 equal to 4, equal, for the I2, V1 plus 4 voltage, because we have the voltage source at the series circuit for that one, minus V2, and divided by 1 plus 2. 1 plus 2 because the total of resistor in the series circuit. As we can see, there is a series circuit, plus V1 divided by V2, which is the I4. As we can see at the I4, the higher one is V1 minus 0, the ground, so it's only V1 minus V2. And next, we need to make the numerator same, so we divide it by using the simple mathematical knowledge, and from there, the numerator, which is 12, will be times with the negative 2, and we can get the equation right here, and the final equation for at node V1, which is negative 13 V1 plus 7 V2 equal to negative 8. That is for equation 1. And next is KCL at node V2. For V2, I2 plus I3, which is the current entering, equal to I1 plus I4 current leaving. And we did at same with the V1. We create an equation. And lastly, we get the final equation at V2, which is 7 V1 minus 11 V2 equal to negative 64. And that is equation 2. And then we combine together equation 1 and equation 2. We can use either the matrix form, but right here I use the calculator to find the value of V1 and V2. And lastly, we get the V1 equal to 5.702 volt, and then V2 equal to 9.447 volt. Next, I will explain the calculation at task 1, but for question 2. And for the question 2, the question asks us to find the mesh current at I1, I2, I3 and I4 by using the mesh analysis. A mesh analysis is a method to calculate a current in a loop form. So for mesh analysis, we apply the KVL, which is the Kirchhoff voltage law. The Kirchhoff voltage law stated that the total voltage within a closed loop is equal to 0. And from there we can create an equation to find the current mesh. And right here, from the KVL, we can find the mesh at I1. From there, we get the 2I1 plus 4I1 minus 4I2 plus 4I1 minus 4I3 equal to 0. And the final equation, which is the 10I1 minus 4I2 minus 4I3 equal to 0. For mesh at I2, 8, which is the voltage source, at the I2 we can see that there is a 8 volt for the voltage source. So 8 plus 4I1 minus plus 4I2 minus 4I1 plus 2I2 plus 4I2 minus 4I4 equal to 0. And the final equation, which is 10I2 minus 4I1 minus 4I4 equal to negative 8. We transfer the 8 volt to the other side, so it will become negative 8. For mesh at I3, negative 10 volt. As you can see, at I3 we have 10 volt as the voltage source. The minus value because there is negative and positive. So when the current flow right here, it will become the negative value. So negative 10 plus 4I3 minus 4I1 plus 4I3 minus 4I4 plus 2I3 equal to 0. And the final equation, which negative 4I1 plus 10I3 minus 4I4 equal to 0, equal to 10. And the final one is mesh at I4, 4I4 minus 4I3 plus 4I4 minus 4I2 plus 2I4 equal to 0. And the final equation is 10I4 minus 4I3 minus 4I2 equal to 0. From there, actually we can use the matrix form, but right here I use some kind of different method. I substitute each equation to find an equation that have a same unknown. And right here we can see the substitute method. And lastly, we can get the value for I2 and I3. And right here I use the calculator and get the I2 equal to negative 0.62 ampere, I3 equal to 1.18 ampere. And from there we can just substitute the value to find I1 and I4. And finally I get for the I1 is 0.22 ampere, I4 also 0.22 ampere. Next, I will pass to my group members, which is Najiha.
Hi, Assalamualaikum. My name is Amira Najiha binti Mak Zain and my metric number is CE220076, and this video is a simulation for task 2. Okay, so this is a circuit for task 2, which is in figure 1. The value for R1 is 1, R2 2, R3 4, R4 2, R5 3, and the last one is R6 5. Okay, next, for the current source, the value for I1 is 2 ampere. The value for I2 is 4 ampere. Okay, the task given is to find the value of V1 and V2. So we need to put a prop at each node to find the value of them. And as I run a simulation, the value that we got for V1 is 5.7 volt and the value for V2 is 9.44 volt, which is the same one that we got from the calculation. Okay, for the next circuit is figure 2, which is we need to find the value for I1, I2, I3 and I4 for each loop, and the given voltage source for this is V1 10 volt, V2 8 volt. So in order to find the value of current, we need to put a DC ammeter to each loop. And as I run the simulation, the value that we got for I1 is 0.22 ampere. And next for I2, the value that we got is 0.62. Okay, for I3, we got the value that we got from the simulation is negative 1.18 ampere, and the last one is I4, 0.22 ampere. So the value that we got from each loop for I1, I2, I3 and I4 is the same as we got from the calculation.
Assalamualaikum and hi, my name is Nuri Shasha binti Rushdan and I will explain task 3 for electric circuit 1. I will read the question for task 3. Task 3. Consider the circuit in figure 3. Find VO by simplifying the circuit using source transformation to a single mesh circuit, so that you need to write only the KVL equation to find VO, given I equal to 2.5 ampere. First thing first, we should know the keyword for this question. The keyword is a single mesh circuit, so need to write on KVL equation to find VO. The given is I equal to 2.5 ampere. For the second tips, we should redraw the circuit after we simplify it. Okay, first, we solve the 6 ohm and 3 ohms because it's parallel. So we solve 2 and we need to redraw again with a simplified one. Because 6 and 3 in parallel, so we solve it with 6 parallel to 3 and we got 2 ohms. Next, for loop 2, we can see it's only 16 ohms and 2 ampere. For 16 ohms and 2 ampere, we redraw again and we short this circuit. And for the volt, we 16 multiplied by 2 and we got 32 volt for this circuit. So for the next, we can see the circuit more simplified than the first one, because first we settle the loop for the loop 1 and then we simplify for the loop 2. For loop 2, we can see it's in series, and then we for the calculation we can calculate for V equal to negative 32 plus 8. Why negative 32? Because the current in negative source, and then for the 8 volt in positive, and then we get negative 24 volt. For the resistor, 16 ohms plus 20 ohms, and then we got 36 ohm. Because it is in series, so we plus it, and then we got the answer. In this part, for loop 1, the calculation is V equal to 3A multiplied by 12, and we got 36 volt. Next, we redraw the new one circuit because we settled it and only left 2 loop. For the calculation, we use formula V per R. V is 24 and R is 36, and we got 0.67 ampere. More simple than before this. And the calculation is R equal to 36 parallel by 12. We got 9 ohm. As we can see in circuit, the 36 and 12 in parallel. So we parallel it and we got 9 ohms. Next, we redraw again the circuit because it need us to see what we have done and undone with the calculation. So for the calculation in this circuit, V equal to IR for the formula. So I shows as 0.67 ampere, and then for the R is 9. So 0.67 ampere multiplied by 9, and we got 6 volt for this calculation. Let's redraw circuit. We can see it's more simple than the question. In this circuit, we can see only has 9 ohms, 6 volt, 36 volt, 19 ohms, and VO, what we want to find. And then this circuit in series. So for the calculation, we use Kirchhoff voltage law as question need. The equation is negative 6, negative 36 plus 28 in bracket I, negative VO equal to 0. Next, negative 42, because we calculate the negative 6 and negative 36, we got negative 42, and then it's still same, the plus 28 and I we replace as 2.5 as question state, and negative VO equal to 0. For line 3, negative 42, positive 70, negative VO equal to 0. Then negative 42 plus 70, we got 28, and negative VO still in same condition, equal to 0. Then to positive the VO, we should bring it back, and the answer is 28 equal to VO. So we got the answer.
For a conclusion, our group be able to use a different method, a different rules that we apply to calculate the value for this task. And we also be able to use simulation tools, which is the Proteus, to verify and simulate our circuit and verify our answer. We also be able to work in a group to done this group project, and we done a group presentation together. I think that's all from us. Thank you.